Greetings, math fans. What we're going to talk about now, math fans, is more trig functions. And let's start out with a couple basic things, and we're going to move on here. But basically, if you are given the quadrant, the question is the ratio, which I will give you, is the ratio positive or negative? Okay, so here's a couple examples. I tell you it's in quadrant 4, and I give you a ratio, x over r. And I just want to know, is that positive or negative? Well, what you need to do is, it doesn't hurt me here, make a sketch. You're in quadrant 4, right? And guys, just to recall how to remember quadrants, right? This is quadrant 1, 2, 3, and 4. And you know that because of conant, cougars. 1, 2, 3, 4. Okay, you got to know that. All right, so let's get rid of that C here. All right. So we're in quadrant 4, and what is the value? What do you know about R always? R is always positive. That's huge. R is always positive. So really, I'm looking at the x value. Is x positive or negative here? Well, don't you guys agree it's on the right-hand side? So all x's are positive on the right and they're negative on the left. You know, if you plot a point, right, x would be positive on the right-hand side. In quadrants 1 and 4, it would be negative in quadrants 2 and 3. So x is positive here. So I really have a positive over positive, which is positive. That's the answer to that problem. It's positive. Here's another example. Quadrant 3. Okay, it's x, and here's I have to give you a ratio x over y. So it's the evil distant cousin, the xoi. Okay, well, look at quadrant 3. What do you know about quadrant 3? Isn't y negative because it's on the bottom, and x is on the left, so it's negative. So it's a negative over negative. And negative over negative is a positive. Okay? Here's another example. Quadrant 2, x over r. Okay? Which you guys should recognize as what? Cosine. X is nose. Okay? What's that? Well, let's check it out. We're in quadrant 2. We're over here. What's x here? Isn't x negative? Because on the left-hand side. So it's negative over a positive. Remember, r is always positive. Negative over positive, if you divide that, you get a negative. Okay? So that's the first kind of problem you got to be good with. It's really easy. Make a sketch to look to see where it's positive or negative. It's really, really easy. Okay. Let us talk about trig values of quadrantals. Okay, and you're like, what's a quadrantal? Okay, quadrantal, what does quad mean? Quad means 4, right? So there are 4 locations here. Here, 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 and here. Okay, basically on the x and y axis. All right, and the degrees are 0 degrees, 90 degrees, which is on top. To the left is 180 degrees. Bottom is 270 degrees. Okay, those are our quadrantals. And we're going to use something called a unit circle. And if I actually have a coordinate for each one of these, let's just use this picture here. This is going to be 1, 0. A unit circle, by the way, has a radius of 1. So even though I'm not going to draw a circle here, if it's a radius of 1, this is 1, 0. This is 0, negative 1. This is negative 1, 0. And this is 0, negative 1. Okay, so you got your 4 corners. And what we're going to do now is we're going to find all the values of sine and cosine and all the different trig functions here, okay? So, let's do that. Sine of 0 degrees. Well, remember, sine is y sin, right? Y over r. So let's look at if I look at here, let me label this too. I'm going to label this in red so it sticks out. This is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. Okay? And sine of 0, it's y over r, so it's 0 over, what's r for all this? Well, r is 1. Now, it's only 1 for this problem. I'm just using 1 because it's a unit circle. Okay, otherwise you can always figure out what r is, but it's only for this problem. It's r is equal to 1. So we have 0 over 1, which is 0. So sine of 0 is 0. Let's do sine of 90 degrees. Well, it's y over r. So it's, this should have been a 1 here, not a negative 1. Sorry, I don't know why I have a negative 1 there. It's kind of messy. In fact, I'm going to erase it to fix it. Okay, and so this is a 1 here. All right. Anyway, sine of 90 is, again, y over r, so it's 1 over 1, which is 1. Sine of 180 degrees is 0 over 1, which is 0. And sine of 270 degrees is negative 1 over 1, which is negative 1. Now, if I keep going here, math fans, I'm just going to do it here. Sine of 360, it goes back to 0. I want to make a point here. You don't need. We're going to learn how to draw this picture later on, but I want to make a quick sketch of what sine looks like. This is a sine graph, and the highest value you can have is 1. The lowest value you can have is negative 1. And if I label all this, this is like saying 0 degrees here. This is 90. This is 180. This is 270, and this is back to 360. So check it out. It's going from 0. So I'm going to highlight, let me highlight this with the highlighter here. 0 to 1 to 0 to negative 1 back to 0. Okay? So in other words, it doesn't get any higher than 1, doesn't get any lower than negative 1, and it follows the pattern of 0, 0, 1, 0, negative 1, 0. Notice it never skips. It never goes from 1 to negative 1 or negative 1 to 1. It always has to go to 0 first. So I'm going to tell you guys, probably one of the more important things to memorize is the starting location. This guy right here. Because if you know it starts at 0, it just goes up from there. And it goes up to 1, and then back down to 0, negative 1, and then back to 0 again. Okay? So, because we're going to learn all these different trig functions, if you know where sine starts, you're in good shape. All right, let's do cosine. It's the same idea. Cosine, you know, is x over r. So cosine of 0 degrees is 1 over 1, which is 1. Cosine of 90 degrees is 0, right, x over r, 0 over 1, which is 0. Cosine of 180 degrees is negative 1 over 1, which is negative 1. Cosine of 270 is 0 over 1, which is 0. And cosine of 360 is back to 1. Now if I make a quick sketch of cosine, this is what cosine looks like. Okay, so again, our maximum value is 1, our minimum value is negative 1. So this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and this guy right here then is back to 360 degrees. Okay? And notice how what happens with this one. This one starts at 1, and it never skips to negative 1. It always goes to 0. So here it is. It's 1 to 0 to negative 1 to 0 to positive 1. Okay? So another important thing here, math fans, is cosine starts at, this is the important one right here, it starts at 1. And the only place it can go is it can go down because you can't go any higher than 1. Okay, so it's great knowledge to have is cosine starts at 1, sine starts at 0. Okay? Just talking about the range real quickly. The range of sine is between, remember the range is the y value is between negative 1 and positive 1. We know that because here it is. This is 1 here and negative 1. And what's the range of cosine? Same thing. Negative 1 to 1. It can only be between negative 1 and 1. And notice too, this repeats, right? It goes when you get to here. Why does it repeat when you go from 0 to 360? Because it's coterminal. I can rewrite 360 as 0 degrees by just subtracting 360. Okay? So that's very, very important. Let's look at a couple others here. Okay, we have sine. I just need to make a little room so we can do it right over here. Let's look at tangent. So tangent of 0 degrees. Well, a nice little friendly thing here is tangent of theta is equal to sine of theta over cosine of theta. It's kind of nice to know. Just keep that in mind. Okay? We're not going to use it quite now, but that's okay. You know, tangent is y over x. So let's go back and let's look at our picture here. Okay, I just want to bring up our picture over here of the unit circle to help you with you know, plugging things in for y over x. So tangent of 0 is y over x, which is 0 over 1, which is 0. So tangent of 0 is 0. Tangent of 90 degrees is 1 over 0, which is undefined. Tangent of 180 degrees is y over x, which is 0 over negative 1, which is 0. And tangent of 270 is negative 1 over 0, which is also undefined. Okay, so let me cursor down here a little bit now. Tangent, I don't want to graph tangent because it's actually a little more complicated, and we'll get to that in a couple of chapters here. But I want you guys to understand the starting point again. I think it's always an important thing. The tangent always starts at 0, and then it goes to undefined to 0 to undefined. Okay? Well, let's look at the other reciprocal functions real quickly here. And let me back down here again. If I look at cosecant of theta, right? Isn't that just a reciprocal of sine? So what's sine of, so that's 1 over sine of theta. So if I do cosecant of 0 degrees, that's easy. You know, why memorize all the cosecants and secants and cotangents when you really just have to memorize a few things and then you just do the reciprocal? So if I said cosecant of 0, it's what's sine of 0? Oh, it's 0, 1 over 0. Oh, that one's undefined. What's cosecant of 90 degrees? Well, what's sine of 90? Oh, it's 1. Oh, okay, reciprocal of 1. Oh, it's 1. See, so you don't really need to memorize a ton of different things. Okay, it's too much stuff to memorize, and I just choose not to. Let's do a couple. Let's do secant. What's secant of 0 degrees? Oh, that's the same thing. Remember, secant is 1 over cosine. Well, what's 1 over 1? Oh, that's 1. Oh, God, it's so easy. Now, the only weird one, math fans, is we're talking about tangent. If I said cotangent of 0 degrees, well, that's pretty easy because tangent of 0 is 0, so it's 1 over 0, which is undefined. The only thing that's weird, if I said cotangent of 90 degrees, you're going to look at this and say, well, tangent is undefined. So you're going to say 1 over undefined. You can't do that. That doesn't make sense to do 1 over undefined because you're going to say it's undefined. So think of the ratio. If it's undefined, look at the original ratio here, math fans. Look at this ratio. It's 1 over 0. So isn't the cotangent really 0 over 1, which is 0? So keep that in mind. If it's undefined, and you're taking the reciprocal of it, it's probably going to be 0. Okay, it is going to be 0 because you had to have a 0 on the bottom anyway, so the 0 is not going to be on top. Okay? So just keep that in mind when you're actually doing all this. Now, again, I'm trying to give you guys starting points. I'm trying to tell you sine starts at 0, cosine starts at 1, tangent starts at 0. Okay, if you're not sure, you can always go back to this guy right here and draw a unit circle and just plot some points and do x and r's and y's. Okay? So it's really not that bad. I just got to, like I said, kind of put it all together and you're good to go. Okay, let's do some problems here now. If I do, this is basically it'll say evaluate. And basically, I'm just going to do like 3 sine of 90 degrees. And what you're going to do, it's like saying 3 times sine of 90. Well, this is the deal. Where does sine start? It starts at 0. So it goes from 0, what's sine of 90? 1. 0 to 1 to 0 to negative 1 to 0. So it's 3 times 1, which is 3. Pretty easy. Here, let's try another one. 4 sine squared of 270 degrees. Well, this is what this means, and I don't want to confuse you, so I'm just going to explain it right away. This means 4, and I take the sine of 270 degrees, and then I square that value. I don't square the 4, I square the sine of 270. Okay, please don't square the angle. That's brutal. Okay, these are equivalent. You need to know that. So it's 4 times, well, what's the sine of 270? Well, we're over here, so it goes from 0 to 1 to 0 to negative 1. So it's negative 1 squared. Well, negative 1 squared is 1, so 4 times 1 is 4. That's the answer to that problem. Okay? Okay, let's do another one here. 5 cosecant squared of 270 plus 3 cotangent squared of 90. Brutal. Brutal. It's not that bad. I don't know cosecant. No clue. But I know cosecant goes with sine. And what's the sine of 270? Oh, yeah, we did that one already. Sine of 270 is negative 1. So negative, and that's reciprocal of that, isn't it? What's the reciprocal of negative 1? Just negative 1. So it's really 5 times negative 1 squared, right? Which is 5 times 1, which is 5. Okay, so that's that part. Let's do the next one. Again, we're at cotangent. Well, I know tangent of 0 is 0. This one's undefined at 90 degrees. So cotangent is the reciprocal of undefined, which again, remember I told you that? It's really 0. So it's plus 3 times 0 squared, which is plus 0. So my answer is 5 plus 0, which is 5. Okay, you have to be so careful with your evaluating. You got to get them all right. Okay, it's really, really, really important. Okay? And okay, and that's pretty much it, math fans. Again, make sure you know those ratios. You can draw the unit circle, and make sure you know those quadrantals. Very, very important. Starting location, super important. All right. Okay, so pull out your graphing calculator because we're going to be using that now. We're just going to do a couple basic problems here, and we'll be good to go. So let's just do. I want to do sine of 90. So sine of 90 degrees. Okay, so let's pull up our calculator here. And the first thing you got to do, make sure is you've got to be in degrees. So hit your mode button. And let's go mode. And we're in degrees. Okay, that's good. If you're in radians, boo, bad. Okay, you're not going to get it right. So we got to be in radians. So what we're going to do is let's quit out of here. So second quit. And then we're going to do sine of 90. You guys, you don't need to use the degree symbol. In fact, I don't recommend using the degree symbol unless I give it to you like sine of 90 degrees, 23 minutes, 15 seconds. Then you actually have to type that in. Okay? But, and it's a good habit to close your parentheses and just hit enter. Well, what's sine of 90? Remember, sine starts at 0 to 1. So, 1. Hooray! Okay? That's pretty easy. Let's do tangent of 90 degrees. What's that one? Well, look back at your notes. Isn't that one undefined? So let's see what the calculator says. Tangent of 90. Tangent of 90. Enter. Error domain. Error, E-R-R, error domain. Please don't write that as an answer. Okay, if I ask you what is the tangent of 90 and you tell me it's error domain, boo, I'll mark it wrong. You need to tell me it's undefined. Okay, but that's what it means. It's what's going on. It can't do 1 over 0. So it's giving you an error. Okay? Let's keep going here. It's not too bad. So let's quit out of here. Let's talk about secant of 90. Okay, remember, it's 1 over the cosine of 90. It's the reciprocal of that. So whatever that ratio is, Let's, guys, remember if we're at 90, right? We're up here, so it's 0, 1. And cosine is x's and o's, so it's x over r. So this is r over x. You guys agree with that? And r, of course, being 1 for just this problem, so it's 1 over 0, right? And so what is that? That's undefined. Now your calculator is not 100% smart, because sometimes it, if it's undefined already and you try to take the reciprocal of it, it'll give you an error. Okay, well, I want to get to an example in a second here. In fact, let's actually, before I even do that, see this guy right here, tangent of 90? What if I did cotangent of 90? That's actually the best example. Cotangent of 90, isn't that the same thing as 1 over tangent of 90? Okay, watch this. Let's look at our calculator. That's why your calculator is not super smart. I'm going to do 1 divided by tangent of 90. And that should give me 0, right? If you look at your notes, cotangent of 90 is 0. But watch. Why is it doing that? Let's go back to that. Why is it giving us an error? Well, it's giving us an error because it's doing tangent of 90. It's not doing cotangent. It's doing tangent of 90 first, which is an error, and then it's doing 1 over error, okay, which still gives you an error. So that's why you have to kind of be a little smart, and you have to know it. You can't rely on your calculator every time. All right, so just kind of be careful about that. Secant of 90, that's pretty easy. So let's just do 1 divided by cosine of 90. Well, what is that? Okay, dividing by 0. Isn't that error again? Can't do that. So secant of 90 is undefined. Okay? If I did secant of 0, what's secant of 0? Isn't that just 1 over cosine of 0? Remember, cosine starts at 1. So let's do that. 1, let's quit out of here. 1 divided by cosine of 0. 1. That looks reasonable. Let me tell you a couple things not to do. First of all, see this? I'm trying to use my arrow here. You can't see that sine minus 1 and cosine minus 1 and tangent minus 1. These are not to be used now. This does not, sine minus 1, even though it looks like you want to do a reciprocal, that is not 1 over sine. So it is not cosecant. And this is not secant, and this is not cotangent. Don't use those. This is something we're going to use later to actually figure out the angle. So don't use those buttons. Very, very important not to use them. Okay, and also if I want to do secant of 90, and let's go back to secant of, let's do this one, secant of 180. Let's do that, secant of 180. Let's do that in the calculator. So it's 1 divided by cosine of 180. Well, what's cosine of 180? It's -1. So this should be -1. A really bad thing to do, and I'm going to clear this out here, instead of doing 1 divided by cosine of 180, this is what people do. So you're really supposed to do 1 divided by cosine of 180. What people like to do is sometimes they do cosine of 1 divided by 180. Boo, that is really bad. So guys, I want you to understand that 180 degrees and 1 over 180 degrees have no relationship at all. There's no relationship between these two. It's like saying, oh, I'm 17 years old and this person's 1/17 of a year old. What? Why would you even compare that? Okay, there's no relationship between that. Or saying, oh, what's the temperature outside? Oh, the temperature is 75 degrees. Oh, here it's 1/75 or 1/75 of a degree. Okay, what does it matter? 1/75 versus 75 degrees doesn't really matter, right? There's no comparison between the two. So do not do this. This is really, 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 really bad. Okay? So you always do want to do this route here. All right, so anyway, that's it a little bit with the calculator, and you guys have an outstanding day. Adios, math fans. Goodbye.